Okay, today we're going to talk about section 12.2, surface areas of prisms. And, oh, nice pretty prism. And yeah, the light comes through and it forms a rainbow, but the shape here, this is considered to be a prism. All right, normally if this was in class, I would have you like move these around, ooh, fun, fun. But I think I've already kind of categorized them. They were all mixed up before. Prisms, kind of look here. The bases are going to be the same. Okay, this up here is the base. There's actually another triangle down here underneath. Bases are the same. All the faces, and we're going to talk about this too a little bit in class when we do the net, so probably you'll have seen this, actually made these. And once again, your faces are rectangles. All these faces are rectangles. Faces are rectangles, and you have a base, and there's another, what is that, an octagon? There's another octagon underneath, even though you can't see it. That's what it's like standing on. These are not prisms. First of all, that's a two-dimensional figure. It's not even three-dimensional. Okay, this has the curves in it. The cylinder does not have rectangular faces, so that disqualifies it from being a prism. These have triangular faces. Okay, so that makes it not a prism. We will talk about what most of those shapes are in a little bit. Let's see if I look at some other ones here. I don't know if this will help, but these are other examples. Hold on, keep watching. These are other examples of prisms. All right, well, this one's falling apart on me. I'll move it over here so you can see better. All right, there is basically it's a box, okay? And if I fold it open, we're going to be looking at surface and lateral area. And basically if I take, let me zoom out a little bit, take this and take away this, the base, this is called the lateral area. I know it's hard to see, but you'll see one in class as well. Okay, but in case you missed or didn't get that. So once again, I can fold it up. There's my lateral faces, and then here's a base, and then here would be the other base. It's the same base on the top and the bottom. All right, let me give you another example. Okay, this is a cube. Okay, it's actually a square prism. Okay, the faces are a special type of rectangle called a square. And if I fold this open, okay, remember this was the base. I'm going to zoom out for you. Oh, that's it. That's all I can zooming out I can do. Okay, I'm going to kind of move this around. This one doesn't count, but all of these are considered the faces, and we're going to call that lateral area. When we throw in our bases, then it's surface area. Okay, so let me give you an example of that. Okay, here's a nice, once again, another kind of box. It's a rectangular prism, is what we're going to call that. And actually, interestingly enough about rectangular prisms, they could be the base, could be this. The base could be this. The base could be this. Okay, hard to see. Once again, we'll have actual, these. You can touch them anytime you want in class. Anytime you want. Okay, you can come up to the, I don't know where we're going to set them, on the bookshelf or wherever, and you can come get them. Now if I untape all of this, then all of the faces and even the bases are laying down here. Okay, all of this together, moving it around, I know it's hard to see with that glow, is called surface area. If I take out the bases, lateral area. Oh my gosh, think of the thing. Lateral area, surface area. Lateral area, surface area. Fun, fun, fun. All right. I don't have a lot of those, but here are some other examples of prisms. Prism, once again, hard to see. So I'm turning it around. That's a triangular prism. Here's another triangular prism. Okay, you name it by its base. Here is a hexagon, but since it has, it's a prism. Now, here's the deal. Is it hexagonal, hexagonal. I always say hexagonal. I don't know if that's accurate, but I like to call it a hexagonal prism. Okay. Lateral area would just be the rectangles. Surface area is all the rectangles plus these bases. Surface is all the surfaces. Lateral, kind of think of a lateral pass in football. It's on the side. You make a pass to the side. Oh, this is on the side as well. Okay. All right. And then, of course, I have a rectangular prisms and a square prism here. Okay, this is a special type just because the base is a square. Yeah, so that's what you got. All right, moving on. Here we go, lateral edges. So here you can have another picture if you want to throw this in your notes. And by the way, I'd be taking darn good notes on this section 12 too. Hint, hint. Take some darn good notes on this section. Lateral face. Okay, this is a lateral face. I'm going to shade it in. I knew this was going to happen. I have a feeling I finally figured out it's something to do with this overhead when I show that. Never mind, it doesn't matter. Here we go. Here's a lateral face. Oh, goodness. Here's a lateral face. I'm going to do that in red. Basically, that rectangle is a lateral face. A lateral edge would be, here I'm doing red again. It's where the face meets another face. There's a lateral edge. Here is a lateral edge. Here is a lateral edge. It's where this face right here meets this face, even though that face is in black. Altitude is how tall basically your prism is. And it has to form a right angle. There's lots of rules with this, but basically our altitude, when we talk about prisms, it's just going to be how tall our prism is. It has got to be perpendicular to the bases, according to the book, an endpoint in each plane, so an endpoint has to be on a base, on each base. The height of the prism is also the length of the altitude. Okay, lateral area. Lateral area is going to involve all of this, all of these rectangles. So rectangle here, rectangle here, rectangle here, and actually there are 3 more rectangles on the back side that you can't see, but you're looking at a 2-dimensional picture. Surface area is all of these lateral areas, okay, and then the 3 more in the back, plus the base, and plus there's like a base back behind there that you can't see, and that all comes together to be surface area. So you're going to think surface area involves every single surface. Every single surface is involved in the surface area. All right, now formulas for this. Okay, let's explain why. The reason, now this is your base. Oh dear, and this is a base. Let me make my writing a little bit better there. When you look at your bases, if they want to find the lateral area, you could take the area of this rectangle and say base times height. And you could take this rectangle and say, hey, base times height, hey, base times height, base times height, over and over again. Okay, and then, but they're not all the same. Please notice in the picture, they're not all the same areas. Like these 2 match and these 2 match. All right, but if you notice, the height, if you turn it sideways and up on end, I'm going to call this the height. Look at this height. Look at this height. Look at this height. Aren't the heights all the same? And if you look at it, I'm going to put this in green now, the base. The base here, base here, base here, and base here. If you add up all those bases, you actually get this right here. If you just take your height, that's this part right here on that picture. Okay, so when we say lateral area, and I have a tendency to write LA for lateral area so there's less confusion, when you write lateral area, they're going to use perimeter times height. Perimeter, because this is the perimeter of the base. That's what we're talking about when we say the perimeter of the base. Granted, any base would work on this one. And then your height is how tall this figure is. All right, so lateral area is the perimeter times the height. Or you could take the area of each one of these and add them together. Okay, Surface area. The book uses T for surface area. I do not know why. However, I will probably write surface area a lot. We might put T in there occasionally, but kind of be ready for either one. It makes sense to me to put SA for surface area. Now, you're going to have your lateral area plus 2 bases. Oh, wait, your lateral area is this, right? And we just talked about that formula. You're going to add all your base times heights, or the faster way is perimeter times height. And then you have to add in your 2 bases. So let me put that in red. This is a base, and this is a base. Okay, and that's just weird because it's a net we're looking at. So when you add all those up, you get the surface area. And when they put B, you're going to have to be very careful because little b, big B. What begins with B? Okay, it's not Dr. Seuss. This B means the area of the base. Okay, and you have that written down. Right? It's not like a triangle where you have base times height where the little b, okay, that's little b. When you have big B, we're talking about the area. All right. And now example problems. I hope you took great notes over that information that I just gave you.